Is the universe truly everything that exists, or is it merely a fleeting moment in an eternal cycle of universes? British physicist and Nobel laureate Roger Penrose seems to have an answer to this fascinating question. He believes that the cosmos is subject to a perpetual cycle of destruction and rebirth. But it doesn't end there. Penrose claims to have found concrete evidence supporting his cyclic model. Specifically, the scientist has identified a series of mysterious Hawking points in the cosmic microwave background radiation, which could be locations where supermassive black holes from a previous universe evaporated. What we consider basic knowledge of cosmology today, such as the expansion of the universe, was an entirely exotic idea about a century ago. Until the mid-20th century, most scientists believed the universe was eternal and immutable. Sure, stars could be born and die, planets could collide, civilizations could prosper and then vanish, but on a cosmic scale, the universe was thought to retain its fundamental appearance. This view began to change when astronomers noticed that distant galaxies appeared to be moving away from Earth, and that their speed of recession increased with distance. Subsequent studies led to the understanding that it was not the galaxies themselves moving through space, but rather space itself expanding. This discovery led to the definitive abandonment of the idea of a static universe. In the 1960s, scientists realized that this expansion, traced backward in time, led to an initial singularity, the Big Bang, the event that marked the birth of the universe about 13.8 billion years ago. This concept represented a radical revolution in the history of astronomy, comparable to the acceptance of the heliocentric model during the Renaissance. However, this new vision immediately raised a series of profound questions. If the universe began with the Big Bang, what existed before? What did space look like before it began to expand? And how long did it remain in this primordial state? Moreover, according to our understanding, everything that has a beginning also has an end, but what will the cosmic finale be like? Roger Penrose has tackled these questions with an innovative and profoundly philosophical approach. He developed a theory known as Conformal Cyclic Cosmology, CCC, according to which the universe follows an eternal cycle of eons. Each eon is characterized by a Big Bang marking the beginning of a new phase and a distant future in which space expands exponentially, leading to the decay of all matter. In this model, the extreme expansion of a previous eon creates the conditions for the beginning of the next. According to Penrose, the fundamental characteristic of the universe is motion, which requires the existence of at least two material or energetic objects whose distance changes over time. However, in a state of extreme singularity, where no objects exist or there is only a single object, concepts such as space and time lose all meaning. Penrose hypothesizes that, in a very distant future, the universe will return to such a state, from which it can explode into a new existence. In this context, the last elementary particle will decay, and the expansion of space will destroy even the last photon. This extreme condition, devoid of temporal or spatial references, will represent the beginning of a new Big Bang. According to Penrose, therefore, the universe is not an isolated event but an infinite cycle characterized by destruction and rebirth. Penrose claims to have found concrete evidence of his cyclic model in the so-called Hawking points, detected in the cosmic microwave background, CMB, radiation. This radiation, a remnant of the Big Bang, fills the universe and is considered fundamental evidence for the standard model of cosmology. Penrose, together with colleagues Daniel N., Christoph Meissner, and Pavel Nurowski, has identified circular patches in the data from the Planck and WMAP satellites that correspond to multiples of the average temperature fluctuations in the CMB. These points, previously overlooked, could represent the traces of supermassive black holes that evaporated in a previous eon through the process of Hawking radiation. According to this theory, the radiation emitted by supermassive black holes transfers to the new eon in the form of a residual signal visible in the cosmic microwave background. The mysterious patches observed in the CMB could thus represent a true cosmic obituary of a past universe. A crucial element of the theory is cosmic inflation, a phase of extremely rapid expansion of the universe immediately after the Big Bang. While the standard model places this phase at the beginning of the universe, Penrose's theory situates it at the end of a previous eon. In other words, cosmic inflation would not be a unique event but a phenomenon that recurs cyclically between eons. A particularly interesting aspect is that the conformal compression of the distant future of one eon mathematically coincides with the expansion of the Big Bang of the next. However, there is an exception: supermassive black holes, which at the end of the universe would engulf nearby galaxy clusters before completely evaporating. Penrose argues that the energy radiated by these black holes transfers to the new eon in the form of points visible in the CMB, known as Hawking points. The theory of conformal cyclic cosmology is not without its critics. Many scientists believe that cosmic inflation should erase any traces of a previous eon. However, Penrose counters that even black holes, once considered mere mathematical constructs, are now accepted as scientific reality. The debate over the ultimate fate of the universe and the existence of cosmic cycles is far from over. Penrose remains confident that his ideas may one day become part of the astronomical consensus, demonstrating that every end is merely a new beginning. As often happens in science, what seems controversial today may become established knowledge tomorrow. Thanks for watching. Leave a like, subscribe to the channel, and turn on notifications to avoid missing future videos.